Okay, guys, we're starting chapter 2, and I just thought it'd be a good idea to spend some time going over maybe some additional word problems. We'll look at the ones that you had for homework tomorrow. So what I did is I went through and I chose some that were not assigned or some that were similar to the ones that are assigned, hopefully that you could understand it a little bit more. So this is problem number 28. It says a software firm estimates that it will sell N units of a new video game after spending A dollars on advertising, where the function is negative a squared plus 300a plus 6. And 0 is, and I believe they had a less than or equal to here. Whoops, I'm a little bit off. And then a less than or equal to here. So a is between 0 and 300, and a is measured in thousands of dollars. Graph the function using a graphing calculator. Use the maximum feature to find the relative maximum. For what advertising expenditure will the greatest number of games be sold, and how many games will be sold for that amount? Okay, so we're going to want to put this in y equals. This is important. This is my domain. My domain goes from 0 to 300, and once I get it in the function in my calculator, then I can figure out what my range should be. So I'm going to go over to my calculator and type in negative a squared, so go to the y equals and clear out what's in there. So negative x squared plus 300x plus 6 plus 300x plus 6. Now, I know that it's not going to work, but just to show you, I'm going to hit graph. And, oh, I got all kinds of issues going on here. I've got dots, which means I didn't turn my scatter plot off. So let me go to second y equals, which is stat plots, and let me turn that scatter plot off. I'm not going to be needing that. Probably not at all in this chapter, maybe, especially not right now. So then if I go back to graph, well then I can see this line, but I have no idea what it's doing. So let me go back to what they told me in the problem. They told me that my A values go from 0 to 300. So what I'm going to do is I'm going to go to the table and kind of take a look at what's happening between 0 and 300. Now here's the problem. I'm going to be scrolling for days if I'm going from 0 to 300 and I'm counting by ones. So I can tell my calculator to maybe count by tens. So if you go to your table set, here I'm telling it to start at 0, and delta table means how much do you want it to count by, and I'm going to put tens. So that way it's not taking me as long to get to 300. So at 0 it's 6, and then I've got up, so it looks like, you know, low of 6, and then I'm up to 14,000, 16,000, 17,000, still going up, 22,000. Still going, now it's going back down, 21,000, 20,000, and looks like back down to 6. So let me set my window then. So I'm going to hit the window button over here on the calculator. Okay, stop. I hit too many down arrows. It's still going. It'll stop eventually. Maybe. Stop. This is silly. Alright, so I'm going to set my window. My x's went from 0 to 300. And then my y's went from about 0 to 25,000. So now I'm going to hit graph and see if I can see it. Well, look there. It's much cleaner and much easier to see. So that's a good graph. And we just used the 0 to 300 and figured out what our y's should be over that range, and that kind of helped us. So now part B, so A, we've done. Graph the function using a graphing calculator. B, use the maximum feature to find the relative maximum. So I come to my calculator. If I go to second, trace, I need the maximum, so that's number 4. It always asks for a left bound and a right bound, so I'm going to scroll to the left using this left arrow here and push enter. That's going to be my left bound. I'm going to scroll over here and get a right bound. Push enter, and then it says guess. So I'm going to push enter one more time, and it says the maximum value is at 149.99998 and 22,506. The maximum is really, your calculator's done some rounding, so it's really at 150, 22,506. All right, so let's see how we can use that in our answer. Find the relative maximum. The relative maximum is 22,506. It's the y value, remember? And that's when x is 150. For what advertising expenditure will the greatest number of games be sold? And how many games will be sold for that amount? So in units, N is our output, and A is the advertising dollars in thousands of dollars. So when X is 150, so what advertising expenditure is going to be 100 and whoops, I'm going to move down here. $150,000, because it says it's in $1,000, will help us to sell 22,506 games. Notice the input is your advertising dollars in thousands, so that's my A. And then my my output is how many games we are selling. So 22,506. All right, let's take a look at another. All right, here we have a seamstress. This is problem number 34. A seamstress is designing a triangular scarf so the length of the base of the triangle in inches is 7 less than twice the height, h. So the height of this triangle is going to be h, and the base is going to be 7 less than twice the height. So that'd be 2h minus 7. Express the area of the scarf as a function of height. In case you've forgotten, area of a triangle is 1/2 base times height. So for this one, it's going to be 1/2 times 2h minus 7, that's the base, times h, which is the height. And you can leave it like that, or if you want to distribute, 1/2 times 2h minus 7 would be 1/2 times 2h is h, minus 1/2 times 7 is 3.5, or 7/2, and then that's times h, and so if you distribute that, it'd be h squared minus 3.5h. We wrote it and multiplied it all out. All right, another example. An airplane is flying at an altitude of 3,700 feet. So the height of the airplane is 3,700 feet. Flying up here. It's the airplane, 3,700 feet. The slanted distance directly to the airport, this is the airport over here, is d. Express the horizontal function h as a function of d. So when you see something like this, and if you look at the picture in your book, you should hopefully think Pythagorean theorem. So what they want me to do is write the Pythagorean theorem and then solve for d. So this is h squared plus 3,700 squared equals d squared. And if I want to solve for d, all I have to do is take the square root of both sides. So I get d equals the square root of h squared plus 3,700 squared. And you can stop right there. That's all they ask for, is the horizontal distance expressed as a function of d. That means d equals what? All right, one more. A rhombus is inscribed in a rectangle that is w meters wide with a perimeter of 40 meters. So here I have a rectangle, and inside this rectangle I have a rhombus. Try to do this. I'm not a very good drawer. Pretend like that's a rhombus. Okay. The rectangle is w meters wide, and the perimeter is 40. Now, if the perimeter of this rectangle is 40, then halfway around is 20. So if this is w, this side is going to be 20 minus w if the perimeter is 40. Halfway around is 20, so if this is w, this is 20 minus w. Each vertex of the rhombus is a midpoint of a side of a rectangle. Express the area of the rhombus as a function of the rectangle's width. All right, area of a rhombus is 1/2 diagonal 1 times diagonal 2. And you may not know this formula. If I were to expect it on a test, I would definitely tell you. So they just need to know how long is this diagonal, which is w, because this side of the rectangle is w, and how long is this diagonal. It'd be 20 minus w, because this side of the rectangle is 20 minus w. So the area of this is just 1/2 times w times 20 minus w. And you can leave it like that, or you can multiply it out like we did in the last problem. Those are a few examples. I'm going to do a few more that are similar to the ones after this in a separate video.